In the home, we used to heard from our mother that it is very important to clean all the things in our house, including the electrical machine also. But what is the reason behind that? Actually, it's not just for looks. Let's see how the things change when we are just cleaning the electrical machine. In the machine, if we are cleaning the dust, what is going to be changed? Not just for looks. In the electrical load and power draw, if we see, and taking the example of fan blades, there is an increased rotational drag. The motor has to supply more torque to maintain the same RPM. In an induction motor like the most ceiling fans, the extra torque demand increases the slip slightly. Slip increases and hence rotor current increases and hence stator current increases, and which leads to the power factor to be changed. Change means power factor reduces. What is the impact of that? Even if omega, that is speed, is constant, if T goes up to drag, P is torque, P input rises proportionally. This explains why the LEDA study showed up to 23.38 kilowatt hour extra annual consumption for a dusty fan. Actually, what is this LEDA? LEDA is the leading edge dust accumulation. Now the second thing, aerodynamic efficiency drop. A fan blade is like a low speed airfoil, just affect its lift to drag ratio. Dust changes the blade pitch shape microscopically and hence reduces the pressure differential between the blade's upper and lower surfaces. Now let's see what is the imbalance and vibration caused here. Dust rarely deposits perfectly evenly, leading edge gets heavier. This causes the static imbalance. And what is the result? Fe is equals to m into r into omega square. Even a few grams of extra dirt at the tip, which can cause the notable vibration forces, which increases the bearing wear, raises the mechanical losses. What is the thermal impact on the motor winding? More torque demand and hence increases the higher current, and hence there is higher I square R losses also in the stator and rotor. Let's say about if the load current rises about 10%, then copper loss is directly proportional to I square, isn't it? And hence 1.1 whole square is equals to 1.21. This heat buildup reduces the motor insulation life, and we all know that it is about 10 degrees Celsius rise. Every 10 degrees Celsius rise, half the insulation life. Hence, this was the example of the blade of a fan, and as we saw that it is very important to clean the dust from all our electrical machine also. But we have to be aware while cleaning the electrical machines.